Good evening, everyone. How are we doing? So, last stream we started work on the material cache. So it's just a way of basically maintaining a list of what materials are loaded in the renderer. Oh, I've got a bit of a buzz here for me. See if I can correct that. The baby monitor on the on the sound card thing, we're going to call it. Right. Should have opened up that plan, to be honest. Yeah. So it's just in my audio levels. Right, that's better. Okay, so last stream we were working on this sort of like material cache as part of like this change set here that we want to do. This sort of plan basically. So the idea is we want to have like 1,000 unique materials in GPU memory at once. So we want to preserve enough room for them, but they will be at varying quality, basically, varying LOD, right? Different levels of detail. So the smallest I think we went for in the end, I think it was 64 by 64 or it was 128 squared, I forgot. And then the highest resolution is 4K. So essentially we have a 2D texture array for each level of detail. So the texture array has a bunch of MIPs, right? So there's a full MIP chain down to whatever. This might be the 64 by 64. And it's got a texture array. So it's got this basically repeated off into about 1,024 of them. And so this means we can preload, or we can have loaded every single material that we want with inside a level or a region. We'll just decide what that means later on at the sort of the lowest quality. So this means for like all the smaller ellipsoids, for the ones which are bigger, we'll obviously offer higher levels of detail, and those will use the same thing. Again, it'll be one texture 2D array. They'll have many slots, but it has half the amount of slots as this one does. And so we built that last stream with the whole texture arrays. So now we've got to try and so I guess we'll go over what we built last stream. So graphics.h. The wrong one. Internal. So we built this sort of thing here. We have a kind of a material where it just has sort of like an asset path hash, an LOD as a float, the layer index that it is allocated into. So with these two things, you can tell what texture 2D array you're in, and then a reference count based on how many models are referencing this material, then we can unload it. So here's the sort of LOD cache. So for each LOD, we've got an albedo, 2D texture array, emissive strength, metalness, roughness, height, and normal. So these are all different PBR textures, but the texture 2D arrays, so you actually store many textures within one, and they'll have a full MIP chain down to 1 by 1 pixel, depending on the resolution this is at. So there's a bunch of LODs. So the LOD 0 would be 128 by 128, and we have 6 LODs, I think that is. So yeah, that's 6 LODs, all the way up to 4K. So 4K only has one texture in the texture 2D array slot. So we've got this sort of like custom allocation thing as well. We have like a bit set. So that's kind of worked out quite well. And yeah. So we wrote the code to do initializing it, allocating it, finding a material from the asset path hash, or finding an insert, incrementing a reference, decrementing a reference to the material, And now we've got to try and actually use this thing and then process the LODs. So the idea is that the GPU is going to feed back, and this is what we'll do very soon. We might get to starting it today, but the idea is that the GPU is going to feed back based on how big the ellipsoid is on screen and what material it is. It's going to figure out like, hey, what was the biggest one of this material on screen? And then it feeds that back to the CPU. So the CPU can then be like, right, get that new higher quality texture in. So we'll be building that soon, but today what we want to do is get it all kicked off. So we need to go over all the models and when they load, make sure that we can find their material in the material cache. If not, find a slot for it. So like a find or insert, we've got a function for that. And yeah, just do stuff, just getting it ready. Maybe, or maybe doing the actual code, which we've got to get the GPU arrays ready and put the data into the GPU arrays from the CPU side things. So that's what we're going to get started with today. Any questions, feel free to ask away and I'll happily get into more detail. But welcome everyone, hope everyone's having a good weekend. So yeah, where we're starting. There's a thing called, if we have to render a, right. So basically at the start of the frame, we upload our model instances. We then prepare the occlusion buffer, we emit ellipsoids from the model instances which are already in GPU memory basically. Then we do the rendering based on what renderer we're using and so on, right? So right at the start we upload the models. And here is where we decide what materials need to be loaded basically. So this is me code genning, it's temporary code gen code of like, temporary model instances emitting code. So we're just making a bunch of model instances on the screen in some grid format so we can just test what's going on. But in future that is going to come from the game thread or something. So here we're just allocating the model instances and all the GPU side data that we want to send up. And then we are loading it into, we're going over all the model instances and turning it into the GPU side data, and then we're copying it to a staging buffer. This is not really a good idea. We should probably have, like, yeah, this is a bit dumb to be honest. It's like gonna end up being like triple buffer by the time it gets there. Like this upload should happen here, then you write directly into the upload buffer memory, but there we go. Anyway, maybe I should change that now. Let's do it. Model instance is packed. So you upload all that amount, and that is okay. And you just upload some like cool. So if we end up skipping some models, it'll just upload some crap data basically. Doesn't matter. It's fine. So this is where we do that sort of find model. So when you get a model instance, it has like an asset hash or a path hash. We still haven't decided on what we want to do. I think I want to do asset hashes, but I got to decide on that. We're just in the path hash for now. So this can fail. And what to do here? So that's fair if the asset is not loaded into memory, then skip, right? And then, so do you make this final load function using async transfer? Oh, yeah. That should really go inside the function. So what it's trying to say is like, never load a model in here directly. Let a background thread do it. So inside this final load, it's just a bunch of temporary code right now. Because, wait, what's this doing now? Yeah. Oh, this is why we've got a temporary grid. Yeah, there's a bunch of temporary code right now, but the idea is that eventually it's gonna look up the model. If it doesn't exist, load the model into memory. This is what I want to do an async transfer, basically. Doing a background thread, maybe. But yeah, and then just return the model if it exists. But so this is where we need to say if the model isn't loaded. Sorry, the material. That's what we're looking at is material. Okay, hang on a minute. Right, so what this temporary code should be doing is it should probably just be making a lovely array of these guys. Let's call it temp. Ellipsoids. Or just... What's going on here? What's this every frame? Doesn't matter. Alright, that's good. So what we're looking at doing here is a core alloc array of... Again, this is all just temporary code, so it doesn't really matter that much. We want to be using the frame allocator and chuck that in there. Now the frame allocator is not here, so let me just go and get it. Just plop it in there like that. And we need a pointer, and voila. Now these guys have got to... What's going on here? Oh. There we go. So now we're going to upload... Wait, nope, that comes later. We're just going to generate into here. Just get rid of all that crap. This is another bit of temporary code, basically. Let's just wall it off. It's all kind of temp code. Up above as well, just silly little hard-coded arrays. So we're just code generating a grid of ellipsoids here just to demo and test a bunch of things. Temp ellipsoids, chuck them all in, jobs again. So then that's going to go into here. And I guess for now we'll just say source ellipsoids equals temp ellipsoids. We'll comment out the rest of that. And then source ellipsoids count will be temp ellipsoids count. And so the next thing would be, so that uploads the ellipsoid, the model, and yeah, so my thing would be, right, is this code would typically be like, right, get the model from disk, and then we'll basically go and send it to the GPU. Now, you would typically have a list of materials as well. So maybe we'll have a static material list. What would it be? It's called material index. Hey there, Voodoo. Not doing bad, my friend. How are you? Yeah, I'm doing alright. Just been sorting out the wife's car this weekend, like taking it to a place and getting that done. Also just chilling out with the boy. So I've been playing with him. It's been fun. Played my Astrobot yesterday. You know, getting closer and closer to finishing that game gradually. But yeah, how about you? So I reckon our model is going to have like an array of materials, but then each ellipsoid that's packed into there will have a material index that it probably references this material list. So I guess there's going to be like, it'll be based on, you know, we might add support for like material palettes as well, or something like this. So things can sort of be swapped out. You know, you can sort of style things differently, which would be quite fun. It's just, yeah. So basically we're going to have to patch this sort of ellipsoid, model ellipsoid structure, or because the material index has to get patched. So something I want to be careful of. So, well, I guess we can, you know, I want to write the code in such a way that I want to write the code in such a way that in the future I won't come in here and be like just confused about what to do and do the thing wrong. So let's just quickly write it out in a very, just be like model materials. So these are the materials that the model uses, say. A material palette. Instead of the model defining its own materials, it can reference a palette or the instance can can specify a palette. Right. So pretty right, lots of stress because uni, but I passed most of my exams. Well done, congratulations. And I have a few more left to pass. Cool. That's great. Thinking about making a simple Minecraft plan for a project in next semester. That's really great. Yeah, that'd be a lot of fun. There's plenty of ways you can clone Minecraft, and it'll be a great experience because it's a good entry game to 3D, I reckon, and you get to procedurally generate as well. That'd be awesome. All right, I'm just gonna take a quick break. I'll be right back. All right, welcome back, folks. Yeah, lots of fun stuff to work on. Exactly. Yeah, it's a really good project, I would say. Yeah, lots of good stuff to learn. Lots of flexibility and lots of little twists you can do, and it's not too much of a hard game in terms of doing 3D development. More the simpler side of things, which is cool. So yeah, I like this idea. I've had this idea in the past, right? So let's just explain it. So, say if you make a model, and you want to provide customizable, like you want it to be customizable. So when you put like ellipsoids down to represent, a part of the body, and you go, right, it's this. Typically, you would obviously want to select some materials and make it look a certain way, but that's all going to come from like a palette. So the great thing is we can restrict the palette size to like 16 or something. So there's some restriction there, and then it means that when you want to sort of theme it or change it to have different versions of the same thing, you can just swap out of the palettes. Be like for if you like, used to play like an old game on the Game Boy and you swap the color palette out. Same sort of thing, but just for the models. So that'd be pretty sweet. And then you can pack the data down even smaller because all you need is like 4 bits for the material index. Stuff like that brings benefits that way. But so that means, right, in the model, you might actually not know then what the material is, right? So you know the materials based on the material palettes that right, that's interesting. And then that the model instances have. And that means when you want to render an ellipsoid, what you're doing is the model goes up as, yes. All right, the model will just get uploaded as normal, but when you emit the ellipsoids to render in the shader, which I'll show that one, so I can emit ellipsoids. This one here, it just goes over the model. You got this group index is the instance index, so you get the model instance. So in here, this could reference a color palette, or sorry, a material palette, and then the model holds all the ellipsoids, and that material index is a material palette index. And you can use that to reference into the palette to then get your material, and then the material index will be emitted as part of this render ellipsoid. Got it. Got it. That'd be much better, wouldn't it? So I guess let's like design it like that, because that's where I wanted it to go. That would be awesome. So it doesn't have to even be part of this function. Huh. It should be part. So the model could have its default. Right, this would be fun. So I'm thinking so the model, so where's materials? Where's that? Right, material texture. So we need a material section. Let's drop it up here. So I have material texture. Oh, by the way, off stream I did a little bit more work on this. I've basically generated a material asset. Just a very simple, basic, well, a terrible one. But it's all like made into GPU memory, basically. And eventually we'll make some good ones in code. So this is the graphics material texture. And I guess GPU side will have basically the same. Oh, will we? No, this one is used for the editor, I think, basically, or to generate stuff. We might move this one out at some point. Bro, what did I want to make in here? I wanted to make a material palette. So the idea behind this thing is to basically give you material indices. And the material palette is going to be restricted to a certain number. I think 16 is good because it's 4 bits and that's half a byte. Right. It's pretty ideal. It's a good number. So graphics, material palette. Make sure I'm spelling palette right. It's with 2 T's, isn't it? I know it. Right, material palette. Entries. Count 16. Bit long, but there you go. So palette. Right. So what we can do is take this, plop that in there, and voila. So we'll load these will probably be another asset now. Another type of asset. Interesting. Well, not these directly, because these are the ones that are in CPU side. Yeah, so for now, I guess we'll just make a. So we'll probably have a pool of palettes. And again, you probably have quite a lot of these loaded. I'll just say 1024 for now. Or no. So you know, 1024 is the maximum number of materials. If you divide that by 16, that's 64. So it means, but there is going to be definitely a lot of overlap, I think. Anyway. So let's just make one of these pools. So where's the material cache? Is that up above? Oh, it's up there. Right, let's drop that up there. So, yeah, we could just bring the whole thing down into one section. Materials capacity. Some of this is going to be shared between CPU and GPU anyway. Material ID. Alright, there's another one. Material on the object pool. Oh, it's all part of the material cache. Let's just leave it there. Let's just join these sections together, I think. Be ideal. Find a couple of things like that. Let's get all the constants in one place. Nothing go wrong with that, right? Does the job. So, material palette ID. We'll need a pool of material palettes as well. Job's good. Right. Core object pool. So we're gonna have a pool of palettes. Right, so you can't just call that pool anymore, maybe. So instead, now this would be interesting. Whenever you find a model instance, you now want to search and find the palette to see if that's loaded. And if it's not, load that. Right? It's interesting. Right, that's really cool. So that's finding or inserting a material, but then, yeah, do we just make it one big old system? So we could put the material palette in a separate section. That's gonna have, and let's just put it all in one big thing, right? What's the problem with that? What could go wrong there? To do with cache and materials. So maybe we change this function name to find material. Easy and a bit long. So we could call that palette. So that can come from some kind of asset, maybe? Yeah. Same thing, it will be an asset, then you load the asset in. Right. And you can increment the reference on the material. Right. And you would also have a reference on the... Oh my days, these are so... similar. You'd also do the same thing for the pallets as well. Because the pallets be referenced by model instances. Well, but the model instances can change any frame, right? You don't know. You sort of... Okay, so with the material palette, you'll probably go over all the palettes and just be like, you have some sort of like, what is their have they most recently been used? And you'll probably count down after so many frames. And after they've not been used for so many frames or whatever, or so many seconds, then you could probably unload them. Yep, and that will then... Yeah, that's probably the better idea. So you don't really want references for those ones. But you definitely want to be able to process the... Yeah, so you could probably have some kind of like... Probably as floating point, so you can times it by delta time. Probably some kind of like... So every time it gets used, you set the counter to 0. And then when it's not used, it will just keep accumulating. So you want to kind of call it like a unload accumulator, something like that. So we'll look into that as well. That'd be fun. Cool. So how we can get these sort of like palette things? I guess let's write these find or load code. It's just basically copy and paste in these guys. So let's find them in the graphics system. Oh, they're not in here. Why is that? Ah, because I put the word material on the end. Gotcha. So these ones, let's copy paste them. They're very small. Material, material, palette, palette. And we're going to then return a palette ID. So start with the find because it'll be the easiest. Oh, we didn't finish off the data structures. So, right, I guess we'll now call this the material pool. And you have a palette pool. Then you have a material map and a palette map. So maps an asset to a material palette. ID. Nice. Okay. So in terms of all of these things, we've got to initialize. Right, so the maximum number of pallets is probably going to be the same as the number of materials, maybe? Yeah, let's use that. I guess we'll keep the same constant there. Oh, shoot. We'll make it have its own constant so we can track it down easier. And the meaning is palette cap. So we'll make it just refer to this one. Now inside the graphics, when we instantiate the material cache, there's a material pool. And a material map. So this is a palette. Oh, palette pool, palette map. Takes the palettes. Ah, wonder why that wasn't showing up there. Times 16, yeah, for spacing, because it's a hash table. Good, same old job there. Nice, nice, nice. Right, so in this sort of finding code, that's material. Nice. Now this is the palette, so it works slightly differently, right? It doesn't have reference counts and stuff like this, so quite similar though. So this will be palette. So when you have a sort of an asset hash or a path hash, I've still got to decide on what I want to do. We check the hash table to see if that exists for the palette. So it's already loaded basically. And if it's loaded, we're going to get it from the object pool using the ID we've got. And that was up the ref count. Hey there, Captain Chica, how you doing, sir? Welcome, welcome. Hope you're having a good weekend. How's it been? So instead of upping the ref count, we're not doing ref counts here. It's more like keep it alive. So it's actually been used here, so we'll reset the onload accumulator. So maybe we could, well, I could make it a function, but no, there's no point. So we'll call it the palette. Oh, gotcha. Oh, nearly there. There we go. So in terms of, so that's a find when you just want to find it, but not insert. This is the find or insert code. So this is kind of similar. Find or insert this time. This time you're looking for a palette again. Just get all that replaced, I guess. Right. Cool. And where we have material, we're just going to put in palette, and then we'll look at the code to see if the logical is sound. Oh, my little man might have woken up. Okay, so we find or insert. And so we find our insert into the hash table, so we've got this asset hash here. What the crap is this saying? Oh yeah, you need to take the address of is new. Then we've got a palette here. If it's new, we want to try and make a new one, right? So, all right, we're gonna need another variable here for palettes. Nice. So with the palettes count, we say if it exceeds the capacity, then remove it from the hash table and then return null. Up the count, allocate from the object pool, assign the asset path hash ID, I guess. We'll do that one again. Sorry, path hash is a hash of the path for now, but it might be the asset hash later on, we'll see. So we also want to, you know, the rest of it's going to be zeroed, but it's going to, right, so with the material, right, so it's all kind of unloaded at this point, right? So with the material will get loaded later on, right? Good part of some sort of background thing. But then with the palette, you really want like, right, so with the material there is an invalid state. It's in until it's all uploaded and ready on GPU. So I guess we're going to need some kind of state that this thing is in, right? It's either so what states are there? There's probably like unloaded and loaded, is that right? And if it's unloaded, you got to try and load it in. Guess that's basically it, isn't it? So is that just a Boolean? Booleans are really unreadable though. We could probably say material cache bit long. Oh wait, what am I doing? This ain't a strut. Unloaded. And loaded. So the palette is going to have this sort of state as well. And so is the material. Yeah, so you'd have to know, or yeah. So while it's unloaded, right, anything that tries to find the material to try and use it, I guess that's the question, right? If you, so you got this sort of material palette, right? The material palette could be ready to use. Yeah, I think the models are only going to use the materials through the palette system anyway. So the materials could just get loaded, you know, and they could always return the material, and that's okay. But when it comes to the material palette, I guess, is like, so when something asks for it, I guess we can make a function which basically says, is this thing loaded? So after the find or insert, you'll get the handle back for it. But you've really got to ask as well, is this thing loaded yet? Like, and ready to use? Is the question, right? Okay, that makes sense. So it's all zeros, so defaults to that. And then, yeah, so we just learned we need two more functions. We want to know the state of material. And the palette. Those would be very useful. Pretty easy to make as well. So this increment of ref count and decrement is only for the material, because the material works on these models which are kind of persistent and get unloaded, whereas the model instances are kind of given to you every frame, so you don't really keep track of previous model instances at the moment. We might do that in the future, I'm not sure. So all these need to be doing. If you updated to use the material pool, because we've got multiple different pools now. Oh. And the material map. There we go. So this one's just going to do a get on the material. And then return the state. Right. Oh, and we need to get the cache pointer. Yeah, this is something I do quite often. If I've got global, I still put it into a local, because in the future, there's many times when I sort of have had to either move this to a different place or maybe make it into something that's got multiple instances of, and I end up having to change more lines of code than if I just define it once at the top of the function. And it makes the code a bit narrower as well. More narrow. I'm not sure if I said that word right, but there we go. Palette. And the palette ID. And the palette pool. Jobs are good. Right. So that's the sort of material cache updated for this palette concept now. So we don't really have a palette file, right? So we're gonna have to obviously hard code one, but so let's figure out where. So let's go back to the header file. There's that sort of, it's kind of the public one though. So the material, the model instance, this guy. So it's going to have a model path hash, and then we'll have a palette. This will be fun. Material palette hash, right? Oh, it's going to be good. And so each model instance can be customized however it likes. And I guess if you don't have one of these and it's like null or something, or 0, then we'll look at the model, and the model's like, I've got a default one, right? Because that's always the thing you can do. And so we find the model, plop it in here. Very nice. Okay, so now this changes how we do things. So now when we do this sort of upload model instances at the start of the frame, we are going to so yeah, this is just code generating some instances that they'll be passed from the game in the future. This goes and uploads them, and it should skip them if they're not loaded. So what we're going to do is go right here. We say if source okay. So if you don't have a what should we say equals, have I got like a just say not. So if you haven't got one of those, so we'll do this like asset hey, you good? Nice. Oh, yeah, you know what? Okay. So this model here, we've got to do a get on the model. I think we have a way to do this. Graphics model get, because it's like an internal thing, right? You would think. Obviously haven't implemented a nice easy to use function. I could use the object pool directly, but I like making these easy to use functions because then I don't have to remember like where the pool lives and stuff like that. And change that in the future if you know, I move things around. Okay. So it's gonna make this thing very quick and easy. So we call object pool get model, and that's in ggfx models object pool, and we're throwing in the model ID on that, right? Cool, just return that like so, and passed in a pointer. Alright, there we go. So now we can do a get, and we're just going to pass in the model ID. Now here we can get the model. Okay. Now if this thing is still null, we'll be a bit extra safe. It should never be null. But if this thing is still null, then we will this should never actually be null. Let's not do that. So I guess when we load the model, we'll just put some extra code in or whatever. Make sure it's not null. Okay, so in here, we're going to now say to the material cache, we've got that function, isn't it? Find or insert, isn't it? Material cache, find or insert palette. So you pass in that material palette. Right? And you should get back a material palette ID. So this means we can say if the palette ID is null, then I think sometimes I like doing right. Okay. So if it's null, we'll just continue and when I should upload it, yeah. So basically it's not loaded. Ooh. Null or not material cache state. Or again. Or if it's unloaded, we'll just continue. So there'll be some other part of the code which is going to look at all the material palettes and try and load them in. if there's room and stuff like that. Okay, now with this, we can then, in the model instance, we can pass in. So I guess we've got room for something else now. We'll have some kind of like palette index, right? So there'll be the palettes uploaded to the GPU. There'll just be like an array of palettes, and inside the palette there is an array of material indices. So we can pack all this down later using the encoder system we've got to really pack this thing right down, like all of the things. So it'd be cool. But for now, we're not doing that. So palette. So there's a way to use these ID. The high bits has the counter for the. So if you dereference it, the counter goes up. Sorry, if you destroy the object or return it back to the object pool, it will up the counter by 1. So we can check for use after freeze and stuff like that. And yeah, so we want to AND it with the ID mask. That's what I'm looking for. So there's 20 bits for the ID mask. So if we just simply do palette id.raw and this, and that will just work out well. So we might be restricted to maybe 1,000, and we'll pack that down later on. Cool, that's really nice. Did I remove some other line of code? Oh no, they get assigned down here. Right. Oh, I've already got that line there. Cool. So that's really good. So now the question is, right, is the palette has to then also load the materials and all that. Yes, right. So I guess we should move on to that code next, is the code which tries to load the palettes from disk and that. So we go to the internal and go to the material cache. So I already made a function called process LODs. So that takes in all the level of details from the GPU and stuff like that. So like after we've read them back, like, so you read them back. So we could call it update. I really despise functions called update though. But, you know, because update is very ambiguous, doesn't mean anything. You know, so what does this thing do? But when it does so much stuff, maybe the word update is okay. Like it's going to process the LEDs from the previous frame on the GPU, basically, or the previous 2 frames, whatever, and will also process the material palettes, try and load them. So yeah, I think we'll just call it update. Not a big fan of that, but there we go. So in here, we're going to go over all the, we're going to do like a, I guess I'll just write this out by hand. Graphics material palette ID. So it's going to loop over all of them. I've got a nice little iterator over the object pool. It's not the best performance, but we can always improve it later. Need a pointer. And let's do a while loop. Iterate to the next one of them. So it'll be cache palette pool, the address of the palette ID, and the address of the palette pointer. So we'll get the cache here, plop that there. Cool. So in here we can go over and process all the palettes. So what we want to do basically is say, right, if the palette state, so if it's not loaded, yeah, no, we just want to just switch on the state, I think. Ooh. Switch on the palette state. Graphics material palettes, sorry, material cache state unloaded and loaded. I think we'll put these around it as well. So if it's unloaded, we want to try and load it. If it's loaded, I think it's as simple as palette unload accumulator. So it's up it by the delta time, whatever that is. Where's my DT? Yeah, we do define the delta time around here somewhere, right? Yeah. Do we want it to come from the game? Yeah, we probably do want it to come from the game. So the payload will hold the delta time. And then that means we can probably just store it globally in the graphic. Well, the payload is going in there. But yeah, it makes it a little bit easier to access is all. So I guess from the game side then, when we make the payload clear. So we're still got to put the correct delta time, but we'll go somewhere around here. Do this properly with time and stuff. And this sort of payload here gets filled up. dt equals dt. And then from the render side, we would like to probably have the delta time thrown in there as well. And then we can simply just, payload well, I think from then on out we want to say ggfx, right? Good. So that function we was in was to do with the cache update, wasn't it? So we're going to accumulate it by ggfx delta time. Now, if the delta time equals, so there's like an unload material palette unload seconds. So the unload seconds will be what? 5? If the material palette is off the screen 5 seconds, then it's probably safe to unload it, maybe. So if the palette is greater than to 5 seconds, now it's time to unload it. Now I think you can unload, because in the iterator, what is it doing? Let's figure this one out. So it's yeah, it's not a callback, right? So it's kind of the state is whatever the user passes in, but the problem is like, so if you deallocate an entry, right? So you get the index, and then we add 1, Right, so if you deallocate it, it doesn't matter, basically. Oh yeah. Beautiful. So yeah, we can do an object pull, deallocate, but then when you deallocate, you've also got to remove it from the hash table too. Oh, that's the void one. What are we trying to do here, eh? We want the ID, so palette ID, and voila. Now in the material cache, we do a find or insert. If we had a full pull, we want to make sure that we did a find or insert on the hash tables that inserted an entry, so we want to just remove that. So we want that remove code here as well. So the palette asset path hash and voila. So it's quite alright. Oh, then you need to make sure you actually take the cache and decrement the number of palettes. Now actually, we didn't do that when we cleared the materials out either. Yeah, when we decrement the reference, yeah, I need to put that line here, but obviously for material count instead. But the number of materials should just be able to come from the pool. Like, why have I got a separate variable? It doesn't seem to make any. The pool already has the variable. Yes, that'll be like material pool dot count. Yeah, I think. Yeah, I think that's right. So that's less error prone as well, which is proper nice. Palette pool dot count. I think that's right. Let's double check the code. So go to the core. We want to do a pull deallocate. So we are right. It gets added to the free list, doesn't it? And then the count never gets decremented. Crap. Right. That's not very nice. Because when we allocate, we check the free list, and then if not, we use the count. Ah. Yeah, so why isn't it decrementing the count? Hopefully I don't break anything. Have a look. Yeah. Yeah. So the deallocators should always reduce the count, because that's the point, right? So it can happen anywhere, which is good. So we can then just say count minus equal 1 and voila. Right, hopefully there's no other code depending on that. I don't think there is from memory. That seemed like a bug. Right, so that's the unload code, the palette. Now when you load it in, this is where we don't have the asset, the custom asset file. And again, we have this sort of like encoder system. So we'll be able to declare our own sort of file format. It could be in text or binary, and get it all packed down nice and small, or human readable, depends on which one we want, right? Binary or text, and then that will be code generated and stuff. So we'll do that later. I'm just not really designing that now, I think. Or could we? All right, let's look at the task lists. Serial plan. So I wanted to do that after Yeah. I wanted to create all the different ones. Okay, so create graphics, material palette. I don't know where this goes. I'll figure that one out. It's another one. So I guess we can do that after we've done all this work and then plug in all the, I guess let's take a couple of streams and edit all of the places where we would we have all this temporary code. So, yeah. So this will load, try and load the asset in. Hey Captain Chica, to move or not to move, home direction. Oh, sorry, home directory. DIR, eh? From 256 gig drive to... Interesting. What have you in your home directory? Have you got any like games in there or anything like that? Because another thing you could do is make, if you got like big things like games or whatever, because games are big these days. About 70 or kernel bills mostly, right? Yeah, so I would say you could just get another drive, right? And have that in a different partition outside the home directory. That's the alternative, right? But then it seems like you keep your home directory between installs, right? I typically refresh mine. And then you could like symlink it or something, if you had a second drive. Yeah. Yeah. Keep on the current one. Yeah, it's better when it's all kind of on one. What I've done right now is I've got a drive for Linux and I've got a drive for Windows. So the install process, I could take out the other one and install it and not accidentally destroy everything. But yeah. That's the way I roll at the moment. I've just got my home drive and everything on the same partition as the OS. So I guess the material palette file is going to have a bunch of... Nowadays, was it? It's an asset path hash. So this would be the materials. Something like that. So there's an array of like 16 of these potentially. So this is what will come from, right? So we don't really have... No. Right, and that's the material file. And the material file has... There's so many references to other things. Indirection. All the way. So this .mat file... Oh, it'll have all the texture data, won't it? Yeah. All crammed in there. Beautiful. So this will just... So let's just say we have 1 for 0 right now. Voila. And then we shall... So at the end of the day, you want to set this thing state to... Oh, okay, crap. Palette state equals loaded. And you also want to... So now you want to go over all of those materials. And then you're going to go ahead and ask the material cache. You can ask yourself, I guess, you know, about whether I can find or insert a material. Just like that. Graphics material. So the thing is, that can accidentally upper reference, then upper reference again. Oh, no, you don't do automatic references. You only increment it when it's a successful load. Incredible. So we could probably want to store as a default, you want to install it in more than one partition. Yeah. Well, yeah. I have a different one for EFI because they require that now. But yeah, I just like nuking the whole system, because the things about Linux is that, you know, there's lots of like these home directories, and that get very like crowded with stuff after a while, and it's just stuff I'd rather not have to maintain, and I'd rather just sort of like have the previous drive around or something like that as a backup, plug it in, take all the stuff I want off when I install a new OS, and job's good. Yeah, I think I only really store an OS when I need to when I've completely messed something up, or need to upgrade the hardware. Anytime I won't bother doing it, obviously. And last time that I hosed my system, I just bought a new drive. Because they're kind of cheap these days. They're like, you get like what did I buy? Is it 2 terabytes or something like that? Yeah, so one terabyte. Yeah. You know, it's like 50 quid or whatever it is, dirt cheap. Nice and easy. Right, so you get your material. So I guess we'll cache these. Have a little cache. Graphics materials. Material palette. Entries count. One of them. So we'd have a little list of material IDs. So we'll just cram them in there. And then afterwards we'll go over them again if they're all loaded and increment the counter. Or increment the reference count. Oh, we've got to decrement the reference count as well, wasn't it? Interesting. Right, so here we look at the material and say, what's the state? Is it loaded? Or is it unloaded? So it's not actually loaded yet into GP memory. Then neither is so I think what we can do, rather than doing a switch statement, we're doing an if statement. Then if the material palette becomes loaded this frame, there won't be a frame of lag for it to get used. Keep all the latency down and all that, you know, as much as we can. Alright, jobs are good in there too. So what we're going to say here is Boolean success if graphics material cache state for a material ID, if that is not loaded, then we're simply going to put success to false and then break, and then only do this if it is all loaded. We go over, increment the reference count for the materials that we've loaded in, and then we say it's loaded. Cool. So my one concern is that there might be a bit of problem with some of this logic that I'm thinking about. Because you haven't incremented the reference count, this material could be loaded. No, it should always... Right. So I think we need a few states. We might want to say... So you read it in from disk, right? And then that's probably done by another thread, and then you get access to it here. So when you get access to it here, you want to go over all of the materials. Yeah, you probably need like to keep track of like how many of these materials have you loaded, right? You'll go over it in a linear list. And then those ones, see, will they have to be material indices? They should be the material IDs. So you could probably want to say the sort of loaded count, but how many of these have you actually incremented the reference count on, basically? Yeah, because otherwise it would have been a case of like, you would try and get these things loaded, but there'll be no reference count there, so it will never want to try and keep that material around or even try and load it, right? So, ooh, right, so when you do a find or insert on the material, oh, it is upping the ref count. All right, we can work with that. We can work with that. Okay. So in terms of like, so this here then just becomes pallet loaded count, right? Starts from 0, and every single time we go around here, we will simply just increase the loaded count by 1, and we store inside pallet the material indices. And then, but only if it was a success. If it isn't, you do a finder insert will increase the ref count. Yeah, I wonder. So potentially here, so you could just process the file and this is another one of those things again that we had earlier, wasn't it? It was like if the material ID or if it's unloaded. But then the problem is you would have incremented the reference count and you'd do it again the next time around, which is a problem. But it's as if like with this palette, you could always just get it to go over all those materials and get those ready. So it only returns null if there's not enough room, basically. Which you should never really do that, but there is a safety. But maybe we should let it go even if it's unloaded. But then when you say that the palette is loaded, then it can be given to the GPU and ready to be used, which is the problem. So maybe we could say it's loaded and then we have a ready state. Let's say there's a ready state as well. So ready would be all of my materials are ready. That'll be it. That makes a lot of sense. So I guess instead we'll say, right, if we don't really care if it's loaded or not, that increments the reference count, and we keep filling those material IDs, and yeah, that'd be good. We probably don't need the loaded count. We could probably just traverse the array and see whether or not it's been initialized. You know, technically we could just get rid of that and just be like, oh, if the material, so the palette material IDs index.raw has something already, we'll just continue to the next one, right? And then you don't need to count. It does an extra spin over it, but it should already happen. Okay, this is looking better. So now on success, we can then just set the state to be loaded. Then when it's loaded, we'll increment the unloaded. No. This would be if it's ready. Ready to be used on GPU. See, when can you clear this? It's every single time you do a find on the palette, isn't it? It resets it to 0, yeah. So when it's loaded, we want to go over all of those materials in the so you go over all the materials, so that would be the graphics material palette entries count. And we'll essentially just keep going. Oh, what is it? You want to say if it's set, we just want to do a get on the state. There's a function for that. So we're saying if those are loaded, then continue to the next one. So I have a boolean here. And we can say success is equal to true. And we'll just and success onto there, right? There'll be something like graphics, material cache, state for the material. Passing in the palette material ID like that. And if that is equal to material cache state ready. So if they're all ready, so we'll skip for null entries. You can probably have some entries which are null. And in that case, when we upload it to the GPU, we might handle that in a different way. I'm not sure. Maybe we'll have maybe slot 0 should be null. And we just have a hard-coded material. Yeah, like a missing texture material or something just in slot 0. But it makes sense. Okay. That'd be cool. So, oh yeah, then this will say if it's a success, move it to the ready state. Rightio. That looks good to me. So that's loading palettes and then making them ready. Oh, okay, so if it's loaded, you probably want to do the upload here to GPU. Yeah, this is where you need to do it. So let's get that GPU buffer ready. And I guess we'll get the GPU representation of the so there's the sort of model instance somewhere. Oh, these are code generated, isn't it? Okay. So let's go to the shared encoder. So this is where we'll pack them down eventually. So this is only for GPU. This is not for the file system at all. So this will eventually be packed. We can have some fun and pack it now. So material palette. And it's going to have an array of materials. We are looking at 10 bits for each material. Although we can't do an array of packed things. Something we can't do. Let's just do full on in 32s for now. It's interesting. Yes, you could have 16 slots. And you could probably... Well, you do 3 in a word, basically. It doesn't divide evenly, does it? Alright. So let's just say an array of material. Material indices, right. So there's going to be 16. We do have constants though. So we could... reference those. I don't know where we'd do that. So you have to use constant expression in this. So we'll say graphics material palette. I said entries count. So the thing is, you can't include files in this. And I wonder if there's any other places that will want to do this as well. Yeah, I think we'll just hardcode 16. Not gonna lie. Let's do that for now. Cool, so we'll regenerate that. So we would like scripts. I think I do slash build slash encoder now. Oh no, I've got a thing for it. Scripts codegen.sh. Done. So let's generate all the code for this now. Okay. So here's where we want to do the upload. So we're in the GPU side of things now. So we should be able to say GPU upload. All right, we've got to get the resource ready first. So we would like a new resource ID to be declared in, so we could put it in the material cache as part of here, because these have resource IDs already. So we could have all the materials, res ID, palettes, res ID. So we'll just initialize those when we initialize the system here, the material cache system here. So this would be a GPU buffer. Wait a minute. Cache GPU buffer init. Something like that. And then the size in bytes. So it will be the number. So graphics, materials, cap, multiplied by size of graphics, material packed or something like that. All right. So that'll be a palette. So they'll be all in GPU memory, which would be nice. So we do have to... Let me look on the... Oh, I didn't say right packed after it. Okay. And we'll need another one for the material itself. So the material itself is probably just going to hold a bunch of read-only texture 2D arrays. Wait. No, not the material. It's probably going to hold a resource and a slice into those texture 2D arrays. Yeah. It should be globally accessible. Wait, you'd have the different... Oh, no. Okay, yeah. It has the resource ID, which would be the texture 2D array, and then the slice as well, packed into a single int. So yeah, we'll get the albedo. So I wonder what we can do for this. We could probably have another... This would be a material texture ref, maybe. So we'll have like 24 bits for the resource ID, and then we'll have, oh wait, we need more bit. Let's say 20 bits for the resource ID, and then we'll have 12 bits for the, so we only need 10 because it's 1024, right, for the slice, the layer. Okay, so you have this sort of material reference here. So yeah, right, that makes a lot more sense. So albedo, emissive strength texture, there'll be a metalness roughness texture, and there'll be a height texture and a normal texture for now. We might add more or remove some, we'll see. Okay, that's much better. Cool, so let's regenerate that. We've got a problem here, there's not a semicolon. There we go, that generated okay. So now we should have a good. Right, create static. Okay. So now they're properly initialized, we've got some structures in there. The next thing we need to do is in the material cache update is we need to now do the actual upload here into that slot. Shouldn't be too bad. Hey, Akal. As far as I recall, you're doing SDF-based shapes for UI rendering, right? Yes. Curious if you have some fancy layout stuff yet. Yeah, I'm doing SDF-based shapes for UI rendering, that is correct. Yeah, currently gone pretty crazy with it as well, basically doing like a sign distance filled virtual machine in the shader. It's definitely a lot slower, but it runs alright on my GPU. And my GPU is kind of like mid-tier graphics card for these days, but on the Intel laptop from like 7 years ago, it's not good. Good way of rendering UI, but it's pretty cool because I can like push and pop distances on some distance stack and do lots of fancy stuff with it. But I think it might be overkill for rendering the UI, and I might do a more simpler SDF based approach where I just switch on a bunch of like predefined sign distance field things. But yeah, I'll answer your question in just one moment. I'll just provide a bit of context here to what I'm just talking about. So yeah, we have a bunch of commands, and each command essentially has a bunch of operations. Like it's just like a virtual machine basically. So you have a bunch of like ops, like hey, I want to push on a shape, a circle shape to the distance stack, so it pushes it on. And then I want to push on a box as well. And then you can have another operation which follows those to pop stuff off the distance stack to say, you know, maybe subtract one from the other, or you do a union, right? And then when you're left with one distance on the distance stack, so you can keep doing this as much as you want. It can get pretty crazy. And then you can basically, when you're left with one distance on the distance stack, you can basically choose how you want to apply the color. So you just be a solid color, a border color based on distance, texturing it, all sorts. So I was thinking you can probably make some like UI to sort of make really interesting graphics with this, like in the in the engine, and probably export that, like basically pre-rasterize it out. But then you lose the ability of it being these cool SDF things. So maybe so 2D animations could be using this, but I'll probably have a more simple version which isn't very expensive, that will just sort of use SDFs to do nice rounded corners and just do boxes, circles, and basically that's it. Not do this very complicated thing. And that will increase the performance, because for the way I do for how much of this I've used for doing the UI, I haven't used any of the extended stuff. All I've done is put boxes down basically. So, Oh, is it like a MIDI mode thing where you build up sort of a command buffer, then UIVM executes it? Yeah, it is. Yeah, it's a MIDI mode. It's every frame. So I've got some test code somewhere. UI shape. Was it UI draw shape? Yeah, UI ABB. Yeah, so you basically just like say UI draw shape ABB, and it sort of just encodes that into the buffer. There's one operation. And then you can say, because there's only one distance on the distance stack, you can then just say, right, here I'm going to apply a color now, and then you say finish, and then that's one sort of draw operation. So that puts a box up, colors it in. But you can do stuff like draw another ABB with some slightly different parameters, and then say UI draw op. You could do morph between the two if you wanted to, or you could say, you could do a union, a subtract, a smooth union on those two things, right? Subtract 2, and that will subtract this one away from that one, right? So if you just put a minus between it. So, and then you can do another thing where you put another shape on, and then say, right, now join these two together as a union. Right, because there's one distance on the distance stack after this operation here, and then that will push on another shape ABB, and then union the two distances together, and then you can put a color on it, and yeah. So it's pretty crazy. Just felt like building something pretty bananas, but it will be flexible for custom render stuff, but not really for basic UI rendering, which is currently being used for. So in terms of like the other question you had, fancy layout stuff, what I'm using for layout is a very simple approach, surprisingly. Why did I just type in the way it's called UI rect in my code base? So rect cut layout. So I just use this one, it does the job. My immediate mode system is purely designed to have no context in it at all, or a very minimum amount of state stored in the UI system. The UI system is designed to be very simple. All of the state for the more complex widgets is actually passed in from the user, and only store like very common simple state like mouse clicks, what is the focus widget and stuff like that inside the system. So if I was just to give you a bit of an example, is a combo box. So like the list, when I do like a list, so this is just essentially that you can have a scroll box and you can list out items in it. You call list start, and you have a sort of list state, and it stores like the scroll, and the item range and some extra bits. So we don't store this internally in the UI system. The user passes this in. So all they have to do is declare it as in some persistent memory, like mark it static or something like that, and then pass it in every frame. And that's where the persistent state lives, is in the user code. Yeah, I try to keep the UI system very simple. And the only state we store internally is stuff like what is the focus state of this widget and stuff like that. So I use this rectangle cut thing. It's quite alright. You can basically, you take a rectangle and you cut it up with simple commands like this. And so you can use it to do, horizontal layouts, vertical layouts, and aligning to the left and to the right, kind of things. And the only downside to this approach is that you need to calculate your widths and stuff with maths, or it be hard coded. Other than that, it means the layout system is purely provided by the user and extremely simple. If the user wanted to pass in a rectangle, which is really weird, they could do that. Obviously, it has to obey the clipping, the clipped area, but you can always make it so they can remove the clipping and put the rectangle wherever they want. But it's super cool and simple. That's why I like it. Yeah, so immediate mode is a lot more simple, isn't it? And like the retained just means you get a lot of like callback type, an event processing type of programming, whereas immediate mode is a lot more. Yeah, so the analogy I will probably use is retained mode is more OOP, immediate mode is more procedural. If you was to give it I would say it's kind of something like that. Right. Yeah, so we'll just upload to the GPU into that super lovely buffer. If your callback needs to change the UI, everything goes to hell. Right. Yeah. It tracks a lot of state as well, isn't it? Yeah, that's the reason why I wanted to go sort of like pure ImGUI, right? Like immediate mode UI, because then I didn't, like, there's less state that's sort of in the system. The more complicated the system is, the more fiddly it'll be to, the more things I have to wrestle with, basically. I want to, one pass, I just want to be able to do all the input processing and rendering as you sort of call the call the code for the UI. I don't want there to be any separate passes and stuff. Command upload to a buffer, cache, palette, res ID, offset question, that is the index of the palette. So that'll be palette index equals palette ID dot raw and core object pool index mask. So put the palette index multiplied by the graphics material palette packed structure, and the size is just one element because we're just uploading a single element here. We could batch it together, but oh no. Oh yeah, we could batch it together, but at most you'll probably only have 1,000 of these. Yeah, but if you have 1,000 in one frame, that's a bit silly. Yeah, so these are quite small actually. Or they could be smaller if I pack them down. So why don't we do this all in one go? Yeah, what are we trying to achieve? We're trying to say... Yeah. Yeah, okay. So I think we'll have this like... Right, in the material cache, I think we're just going to store... We'll store a couple of like material palette packed. This is going to be a CPU side buffer that we're just going to send to the GPU every frame if something has changed. It's just going to be persistent. So palette GPU data, right? Can't get more descriptive than that. Material GPU data. I think the materials do the same thing. So what we'll do is this will just say cache material, sorry, palette I see, I've seen Redcut post before, but I already did run through his UI layout approach. Cool. It's great full test layout where the size of widgets can change. Yep. Yeah, I've done a few of those before. Yeah, when you have the code working, it's great. Like, although there could be lots of little bugs and stuff, but it's great. It also, yeah, you might lose a bit of control though, where you want to put the rectangle in a very specific place or something, but you can always probably make a system to work around that if you do it often. Okay, so here we would like to get the destination and copy it all in. So graphics material palette packed, so we'll call it DST. And we're going to say, so we want to say Boolean has loaded palette false, and we'll make sure we set this thing to true in here. And then we'll simply just say like, well, if you've loaded the palette, then just upload the whole thing. So we'll start at 0, and then we'll just take the whole palette array and upload it. Jobs are good. And so destination, material indices, index. So we'll go over all the material. All the materials, we know they're all loaded. So we'll just do like a palette. Material IDs, index, dot raw and core object, pull index mask. So just get the low bits there. And put them in there like that. Now it's something has changed, and so upload the rest. So that'll be, you take the address here, and then we need to just, when we instantiate the system, we need to make sure we preload these, pre-allocate these arrays. So that'll be material GPU data, core alloc array, graphics material packed, with the allocator, and we're loading this many of them. So that'll be persistent, then the palette, palette, and palette. Cool. Right, so that's the... I'm happy with that. That's the palette loading code. Right, obviously we're just missing the loading from an actual asset file, which we'll do in the future. So that's cool. The next thing I'd like to do is do the material loading code. So this might happen before the palette code because the palettes depend on the materials, right? Awesome. Yeah. So it's really interesting with immediate mode UIs. I think they are basically always the answer unless you're a really large company and you want to have sort of UI designers or whatever directly change the interface of the UI through non-code interfaces, right? Like with like UI designers. But we don't really live in a world where those tools really exist too well unless you build them yourself. So I don't really think they, typically when you have a problem and the UI needs changing, you always need a programmer anyway, right? But when you're in a company, they always like to try and do these things where you can let the UI designer come in and make a quick little change or whatever without disturbing a programmer. So yeah, the whole state of UI is just really bad. If you just build your own tools and you want to solve that problem, I think that's the only legitimate use case where retain mode UI makes some kind of sense. But typically with UIs anyway, all of it's very programmable, isn't it? It's like, sorry, solved through programming, like it's procedurally made somehow. Like you don't typically like hand paint a UI with tools. Like you always have to sort of spawn a bunch of components or whatever based on how many items there are or whatever, So yeah, I would probably never do a retain mode UI. But I've got plenty of time in my life to live, so maybe I might. Right, just take a quick break. I'll be right back. Alright, welcome back everyone. So now let's try and do this, but for the material itself. So this thing's happened before. So how different is it from this? Well, let's just take the skeleton and do it again. So we'll just change the word palette. Well, let's look for the word capital P palette and then remove that from the code. Oh crap, it didn't do all the... How much did it do? It didn't even get the ready code. You bugger. Alright. Gotcha. Any more? Delete. And delete. So the next thing to do, let's get the palette code, lowercase, and replace it with material. So we'll get rid of all the specific logic for the material, sorry, for the palette, and in a second. Okay. So the palette's been loaded, then upload all the materials with size of material. Good. So, right, so to do, you want to load it from an asset file. So you go over all the materials, load it from an asset file if it's, if it's ready. And then right. So this is a... So what are you doing? You're loading the... You're loading the texture data into... So in the material plan, we've got this sort of like graphics material, and it's just going to be a bunch of arrays for texture data for like albedo, emissive, and that all crams into a single asset. So you'll be pulling that in. You'll be uploading. So if the asset's in CPU memory, you'll get that. And so at this point, you will probably be chucking on some sort of like, in the future, some async thread or whatever. And yeah, this would change. Right, I see. Yeah, it will work similar to this sort of system, where the unloaded will just pass it to the async thread, and then the loaded will wait till the async thread has done its job, and then change it to ready when it's done. But in this case, because we haven't got this sort of async loading system, we would instead, if it's unloaded, pull or just upload the texture data to... 2 seconds, let me just move my son around, he's just... Right, I'm back. Yeah, my boy just sleeps next door and he's just rolled around and heard him hitting up against the side of the bed, so he had to get moved. Yeah, so where was I? Yeah, we just want to basically take it and upload it into the slots where it needs to go into, right? So this is interesting. Yeah, so we haven't really got the bit of the code where it's going to obviously change the LODs as well. And if the LODs change, would you then mark it as this sort of unloaded thing? Wouldn't really. You want it as like a, it's kind of loaded, but yeah, that's something we'll have to think about later. So for now, off stream I worked on basically generating a temporary set of textures. Is here gen test material. It just takes the coordinate and generates a bunch of like very terrible albedo emissive, you know, roughness and normal map textures, and then it just puts it into GPU memory. So we have this available, and so for now I think what we're going to do is do that copy code. So this to do load from asset file, right? I think all we're going to do is, it's always going to be a success, and we're going to move it straight to ready, and we could probably get rid of all this. So the thing is, if the state is ready though, we're never going to unload it this way because it gets unloaded through the reference count system, you know? And oh crap. Yeah, it gets loaded through the reference count system, which means when this happens, it needs to be sorry, the reference needs to be decremented, doesn't it? Hang on a minute. So material palette. Nearly missed that. So the graphics material cache ref decrement. Or did I change that to... I think I did. Yeah, I put material on the end there. Okay, so we're going to decrement the reference there, and then that means they can probably get unloaded if they're all 0, which would be good. Okay, so that's why in this code up here we need to keep the check for if it's ready, because if there's no, wait, oh no. Yeah, we don't need the ready state, because when you do this ref decrement, it will say if there's no references left, actually remove it, right? Okay. Good. Cool, so what we need is this. So I've got this sort of texture copy structure. Now I was testing this out actually, so let me find the code I made earlier. It's here. So there's this sort of material texture, which is where it all lives. It's just basically got like, you know, one texture for each PBR texture, and this is what we code generate into. When we're doing our material building system, we'll we'll material generate into these textures and then serialize these out to the material asset file, and then that'll just get loaded in. So right now it's just material generated into GPU memory, so we're just doing the copy. So if we simply say, right, it's coming from... So at this point, we've allocated a slot for it. I think that's right. Yeah, so when you Yeah, so when you do a find or insert, it allocates a slot for LOD 0, which is the lowest level of detail. So we already have a layer index and an LOD as well at 0. So we can literally just say, okay, what is my... We probably want a nice function, maybe. You could probably ask for what LOD cache you're in. No. Okay. Graphics material LOD cache. So this just holds all the different textures basically. So that'll just be for each PBR texture for that LOD. Now what am I doing? So it's cache, LOD cache, or LOD, sorry. And then cast it into an int. So it's a floored. What should we do? A seal? Yeah, probably a ceiling. Raise the ceiling of cast in it as well. Of material LOD as float. Then with that we can copy over the albedo. Now here's the thing, right? We've got to know. So this, we want to know like at what LOD we're at. So it's the inverse of MIP. Oh, it's the other way around, right? So to get the MIP, it's the number of material MIP minus LOD minus 1, right? It's just the other way around. So you have your destination and source MIP. This is just a fully MIP chained 4K texture all the way down to one pixel. So we're saying source MIP, destination MIP into the now your destination MIP will always be 0 because it's specifically for that size. So this LOD starts off at 128 squared. Cool. So now all it's a case of doing is just duplicating this code and looking for albedo. And then this will just copy from that GPU memory where we've got this test material texture. Instead of copying from a temporary material texture. So albedo gets replaced with emissive. Then emissive strength. Then metalness roughness. Then height. Then normal. And then it gets marked as being ready. So this will happen all in a single frame. And then be ready to use. So the material cache update should really happen if we're doing like GPU commands and stuff. It should happen probably at the start of the frame before we do anything. So it's all ready. If it's staged, which probably is. Oh, we've got to be careful. Yeah, I'm not finished here. We're getting close though. So we need to go to emit ellipsoids. Yeah, it's this one here. So we call it, we've got to call it before you Alright, pass in null for now. Okay, so we need to also change So be has loaded material equals true. And we need to do the same sort of thing here where we do that destination and then set all the material slots up right. Hey, welcome back, Captain Chica, sir. Welcome back. Nothing broke yet? Oh, you've been doing your upgrade. Ah. Nice. Very good. Congratulations. Yeah. I upgraded my GPU and then it destroyed my machine. So, that's great. You should be celebrating. Yeah. Turns out, oh, I thought Windows was bad for changing GPUs, but Linux is bad too. Material data, the material index. So material index equals material id.raw ANDed with the object. Something like that, right? Okay. Oh, nearly there. So remember this one. If you remember this right. Oh, for crying out loud, I've already got one of these. Right, this is not going to compile. Unless I can change this. 6. Hang on a minute. So if I rename this to Pact 2, this will be the one we're going to be replacing very soon. Oh, we pushed them on from CPU side? Won't be doing that long. Yes, we used to have them hard-coded like this. Right, okay, this is going to be hopefully easy. So let's go around and put 2 there. Okay, let's keep going. So we've just got one global material right now. That'll be gone very soon. And again, it's in the payload, so from CPU side it gets passed to the renderer this way. Not the best. But then it doesn't, because it's hard-coded, I think. I didn't even know that was there. This is the material cache ones, this is the new packed material that we're sorting out. And this is it here, the new one. Got that texture ref with the res ID and the layer index, which we're going to have fun with. Material cache. Right, this should really just go. Let's get rid of it because we're not going to be doing materials that way and we've not got code which does it that way anyway. So let's just get rid of it now. The more important thing. Is it in the game that does it? Or is it graphics.h? Right, did we do this anywhere? Right, there's the implementation. Aha. Oh, it's done for the material editor. Right. Well, I guess this is broken now because we're completely changing the material editor anyway. This is why we're doing it. Okay, so what will be next? Yeah, there was that material packs, wasn't it? I wanted to see if there was the old one anywhere. Right, there's not, which is good. Okay, so this is what it looks like. It's this. It's just got references to the textures, so we just got to fill in that res ID in that layer index, so the array layer. So from the shader side, we'll be able to sample from that array layer quite nicely. Just don't do what I did. I forgot to create a user directory on my new drive, so now I have to mount the drive. Oh no. Damn it. Could you not just... Oh. Can you not like mount it to a different directory and add the new drive? Sorry, add the directory that way. Just quickly mount it, add it, and then... Oh, wait. I'm not sure why that is. I don't know. Okay, so albedo will be... So this is like a packed thing. So this is code generated. There'll be a way to store it. I just got to figure it out. So it's graphics, material, texture ref. I've got to find it. It's in the shared generated. Yeah, let's reload it. So here's the bit packing stuff it's generated. It's fine, I'm the only one with physical access to the device. I'm going to grab if my YubiKey. Right. Nice. Yeah, I've actually got a YubiKey, but I never got around to setting it up. I got it, I was like, oh, this would be cool. But yeah, I didn't probably realize I didn't need that level of security. But it's still on my keychain actually. I can have it all set up and everything from my laptop, desktop. You want me to set the res ID? Wait, this value is right. Yeah, we're adding it out. And then storing it. Yeah, they're right. Is that 20, what was that, 20 bits? It's 419. Yeah, 04 is, yeah. Then that's all the bits off, cool. It's the max value. Right. Yeah, so it's code gen all good. So we're gonna do a set basically, right? So set the res ID. So in albedo, we're setting it to, so the value is LOD. What would it be? So LOD cache albedo res ID dot GPU resource ID index. This gets us the index into the bindless descriptor. Okay, so that's for one of them. Then you got to get the layer index set up right. So is it? I just remembered. We don't need this packing code. Here's what we need instead. These can all be res IDs. Right, let's go to the material. Right, so maybe we need this material ref. The material ref is nice if you're sort of passing it around though, but you're not. You're going to get the material, and you probably need to know, hey, what is the sort of layer index, because they all share the same one. And these can then all probably be read-only texture 2D arrays of whatever they need to be. Yeah, but so when you get the material, you probably say it's a layer as an LOD. Then these LODs can probably be stored in an array somewhere, and then you won't need to, or maybe they could be calculated with a bit of maths. Yeah, we'll figure it out, but I think we can just do like the layer and LOD, and you can probably cram that down into a single, like the LODs you only need 10 bits. Sorry, 10 values. So you do that in 4 bits. And then you could cram the layer into the rest of them. So that'd be 28. So that's all you need, isn't it? All right, it's regen. So it's just different now. You just need to store material LOD packed LOD set. So in destination, we're going to set the LOD. Probably need to deref that there, like that. And then you want to set the layer index. So what layer it is in the texture 2D arrays. So that will be material layer index. Just like that. And then because we've changed the GPU data, it will then set that to true, and then it will upload all of them again to GPU memory. Oh crap. Let's actually do the mem copy. Core copy elements many, destination, source, and the amount of number of elements. And then the same thing for the material palettes. Oh. Okay. My first bought laptop, they asked if I wanted to have a physical key lock. And I said yes. And everyone's disabling it, right. Sounds like you bought it from a very sort of... interesting. I've never had that when I bought a laptop. Yeah. Right, so... Yeah, I think we'd say that's in a good place there. So this is only like a 32-bit int, then it's all packed down, it's good. You could probably pack it down even further to U16, but the problem is we don't have U16 stuff. We'll see. Maybe you can pack 2 into a single entry and then you've got yourself U16s, but there you go. Okay, so when it means getting... Right, so what's next after this? There's material. Oh yeah. So in this LOD cache, there's these guys, right? These resource IDs. So I'm thinking, right, if we allocate these in such a way, or if we assign these resource IDs in such a way where they're stored linearly, right? So you create the LODs in an order, then... Oh, we create them from back to front though, isn't it? Maybe we have to change that. But that means in the GPU side, we'll be able to basically have a base resource ID or something like that. Or maybe we can... And that could be stored globally. And then you can work out the rest of them with just the LOD. And what texture you want. You probably make a couple of functions to say get albedo texture for a specific LOD. Yeah. Oh no, we do it. Oh, we do it. Why do we do it in reverse again? Right, because I'm working out the number of... So it's stored in high to low. Yeah, it's because I'm working out these array layers basically. Okay. That's interesting. So that's pretty cool. So what have we got done from that to-do list? We kind of remembered that I wanted to do material palettes, so we started doing that. So what have we done from here? Renderer changes. 1024 unique materials once loaded into memory. We can restrict this to per region or per level in the editor. Cool. Yes, we've done this. We end up picking a minimum of 128 squared for the resolution of a material, but we could go lower, I guess. So it just means we won't have to keep loading in new materials and stuff. Just preload it for... We could potentially preload it for an entire region or level kind of thing if we wanted to. Right, so the CPU side code, we've got this sort of material cache thing with these texture 2D arrays of, you know, so many layers and different quality levels, right? And we've got a material array which is mirrored to the GPU, yes. We've also done a material palette as well. We've got a function to take an asset path, turn it into a material index. So that is all done. Mark that off. The model has a list of material asset paths. So this one kind of changed, right? We end up having material palettes and the model just has a default palette and the instance can have its own palettes, and the palette is what drives which has the material indices and drives loading those materials. So this is kind of done. Well, no, it is done. It's just done in a different way. Loop over the material cache and upload the up-to-date graphics material. Yes, we've done that, but in a slightly different way, and done the material palette cache. Read back the LODs. We haven't done that. And then have some kind of like you know, if it's been off the screen, if it's not been used, basically, the material for so many frames, then get rid of it. No, that's not, sorry. Yeah, so the LOD is going to... Right, this is what I meant to say. So the LOD is going to come back, the feedback is going to come from the GPU based on all of the ellipsoids that have been rendered with that material ID. We take the largest one and we send that back to the CPU. And yeah, to save it so that if something gets big then small, it doesn't try and unload and load again. We want it to have this sort of slow decrease or decay on the LOD such that things can increase, probably on the increase as well, maybe a slow increase and a slow decrease perhaps, or maybe a fast increase, slow decrease on the LOD, and that way you won't have stuff load and unload all the time. There's a trade-off there, so it still needs to be done. Loop over the model instances, and if the materials are not loaded yet, then this can be skipped. Yes, we've done that. So I guess next stream we're working on the GPU side code. So we've got it all ready now by the looks of it. We need to wait, does it? Right, let's sort this out quick. Right. Shouldn't be too bad to sort out. Don't think we... Right, in the payload, eh? 1329, wasn't it? Yeah, what is that? Right, 76. We're not making that array anymore. And next study, things should be gone. So it was in the payload to be passed up for the editor. But the editor's not doing it that way anymore, I don't think. We're rewriting the editor anyway, so just get rid of the code. Nothing called palette index. Oh, I changed it in the code gen file, but not the actual file where it gets described. And then delta time wasn't set properly. Right, that should still run, hopefully. Hopefully the render is not broken. Right, the distances between things are a bit messed. That was to do with the model loading code changed. Alright, there's also this sort of thing going on here with the material cache. Let's sort out... Right, I guess let's just quickly mention what we're doing next stream, then we'll finish this off. So, yes, we've done this mostly, which is great. So the only things that's left is doing the GPU side code, where when we emit the ellipsoids to render, we need to emit the LOD and material index to a separate buffer somewhere. And then we want to dispatch a compute shader. We've got 1024 across the group feature thread group, and we store it all into the local device store memory, and basically go over every single ellipsoid we're trying to render and find the maximum LOD, and then and then mirror that out to a feedback buffer that the CPU will read back. So that's the reason why we've got this sort of 1024 limit as well on materials, is so we can do this sort of nice feedback system, and it should hopefully be very cheap. That's the hope. And we'll get a reasonable LOD check without going over all the materials for every CPU side. We should be able to do it. Yeah, we do it CPU side. It'll be a guess, but this is a rough calculation based on the size of the ellipsoid rather than the size of the model, which would have to do for a CPU side one. Then we want to do the ray hit code, make a UV, calculate the MIP level, and then sample textures. So yeah, lots of little stuff to do. So hopefully we'll get this very terrible looking texture on the screen. We'll probably skip this feedback stuff and just try and get the texture loaded first, since it's all there and ready. I think we would like to get the, yeah, we know how to do that. That's good. Right, let's fix the code. So let's comment out this for now. So let's just see, does it still run? We've got gaps at the moment between all these. Oh, that went quick, didn't it? So I think they're there for a frame, then they're gone. So we do a find model. Find or load. Right, so if it's new, so it should just be using, you bugger, I see it. Oh my days, what is this doing? That whole thing should be gone. Okay, so the count was wrong by the looks of it. Well, that's this thing, right? Is it was fine for the first frame. So this was probably fixing the problem where there was just too much of a gap, maybe. No, because it's not a spatial problem if you over allocate. So we used to just upload every frame in the other dummy code. But this allocates a block. Yeah, where is it getting the... Right, returns 0, okay. Oh, the reason why I changed it every frame. Oh crap. Alright, we're gonna bring back the old code. Yeah, the reason why I changed it every frame is because we've got sliders and stuff. Okay. So this is the old code at the start. Well. Okay. Oh, I did that completely wrong, didn't I? Rightio, looking good. And the other thing was that this code was added in here and it kind of messed it up, right? So, yeah, so I kind of commented that out. Let's remove this sort of temp code crap. These commented lines back in. And the fact that we changed... Right, that'd be good anyway. Cool, so that should get us back a working test scene. No. Right, so the problem is it tries to get a model because... Right. Joys. So it tries to get a model right now because there's no palette defined in the model instance. So yeah, I guess for now, to do enable this once we have model assets being loaded properly. That should do it for now. What did I say? Remove this? Oh, enable this. Good, good, good. And still no work. So let's re-enable this. I remember it crashed and we saw them being rendered for like the first frame, I think. Ah, here they are, right? Oh. Are they dependent on the material cache running now? I don't know, we'll see. I think they might be. I have no idea why. Because we're not using the material system to render any of those ellipsoids yet at the moment. That's what we're doing next stream. Okay, so for some reason the LOD cache deallocate is being called because a material got dereferenced. Sorry, the reference got decremented. So 28 or 2710. Nah, not that one really. Right, so we're saying the material. Yes, the palette is ready. Right, interesting. So surely the palette would have been, you would have found the palette, did a find on the palette. Like what palette is this that we're looping into? So go back to that code we had earlier. Find or load. So we're saying do a find or insert with this. And it's 0 basically. But that should happen every frame. And if you... Oh, right. We didn't put this line in here. So what we're trying to say is every single time you get it, I guess. Yeah, so when you make a new one, it's going to be zeroed anyway. So when you get the palette from the pool, you want to make sure you clear the unload accumulator because it's being used this frame. So if it's not being used for 5 seconds, so 5 seconds worth of frames, then we unload the palette. So that should run now. Right, appears to be running. Sweet, there's the test scene. No. How can this still be happening? Alright, let's try that one out again. Right, it's definitely found. Oh, for all those model instances that we're launching. Huh. Beer still. Did I do my comparison operator wrong? Like, what does delta time spike? Oh, delta time accumulates. Isn't that lovely? Because, okay, I added this thing today. I plus equals it instead of equal. There we go. Problem solved. Cool. So, yeah, we can move around. There we go. Nice. Yeah, this is still running all right. Great. Yeah, so right now, as you can tell, look at these ellipsoids. They've got a very hard-coded material. So it's just got a roughness, albedo, metalness. I think that's it for our properties right now. And obviously a fixed normal based on the actual hit off the surface and calculating the normal. So what we are obviously doing is making it such that you can get all this information from a texture, and it means we can get lots of different, rather than one material property for the whole surface of the object. It'll be really detailed, or it could be really detailed if we wanted to. And yeah, you know, these are not limited to spheres, they are ellipsoids, so we might benefit from having a lot of larger ones with lots of different detail. So we could flatten it down to an ellipse and just have lots of like flat surface looking things, but then you will put a different material on it and maybe you can make it look like it is a bit bumpy, but it's actually not bumpy, right? We'll see how things go. We'll have a play around with it. Yeah, so this is what we're working towards, is making this sort of detail more like better without having to, you know, because when you render lots of ellipsoids and they get quite small, we probably want to reduce the roughness. If we have to really play around with the look, basically. Have to have a bit of a play. Try and make it look as good as possible. There's some really weird artifacts we get with the bloom, I think, and the reflectiveness. So I have to look at the texture. So there's the bloom texture when you, well, where's the scene before you render to bloom? This one. Yeah, so they're very bright pixels. These obviously change when you move the camera. And then the bloom picks it up. But the bloom that I wrote was designed to get rid of these very bright. So clear, copy the scene. Yeah, it did say that it was designed to get rid of these artifacts, but ends up just going like that. So there's something probably wrong in the bloom pass, which is causing it to go like that. We'll see. Yeah. I was thinking about maybe up in the roughness, and it might help a bit when they get small. Yeah, I think that's the bloom. Oh, I actually took a screenshot there. Cool, right. So yeah, the next stream, guys, would be on Tuesday, about 3 hours ago on Tuesday, and then obviously on Thursday as well, same time that day too. Sunday is a little bit earlier. There's a schedule in the timeline down below. But yeah, thank you for everyone who's supporting the stream. Really appreciate you guys. You can support it via Ko-Fi and Twitch as well. You get access to the code. Ko-Fi is much better for the supporting. You know, more of the money gets sent to me if it's gone that way. But yeah, there's Discord if you want to come and hang out in the meantime and have a chat, talk about programming. You know, I sometimes share stuff I'm reading on there to do with graphics and programming and stuff. And yeah. Right. Valigo. It's very Valigo. Man, it's been going for 7 hours. I remember these days. This is what I used to do. Right. Have a good 101. I'll see you all later. Have a good start to your work week. And yeah, catch you later. Bye.